Hi, I'm Amelie Cook, and here's a quick lesson on thermodynamics. Here are some key terms you should know. Number one is that thermal energy is the energy within an object due to the kinetic energy of its molecules. It can be transferred as heat. Number two is thermal equilibrium, which is when two substances in a system are at the same temperature. For example, when both ice and water exist at 0 degrees Celsius. Number three is IMFs, or intermolecular forces, which are the forces that hold or bond molecules together. And number four is phase change, which is any time a substance undergoes a transition that changes its state of matter, for example, solid to liquid or liquid to gas. To calculate heat energy within a phase, you use the formula Q equals mc delta T. Q stands for heat energy, M stands for mass, C stands for specific heat capacity, and delta T is the change in temperature. Since specific heat capacity differs for every substance, we can use this formula to identify different substances. In this example, we're finding the heat capacity of a metal. All you have to do is find the mass and change in temperature in both the water and metal and solve for C, since you know that Q of the water plus Q of the metal equals 0 due to thermal equilibrium. To calculate heat energy during the phase change, you use the formula Q equals M times LF or LV. LV stands for latent heat of vaporization, which is the heat required to go from liquid to gas or gas to liquid, while LF stands for latent heat of fusion, which is the measure of heat necessary to transition from solid to liquid or liquid to solid. An easy way to understand how to apply the two formulas we've learned is to look at this graph. Each section where the solid or liquid or gas is warming is when you use Q equals mc delta T, and any section where the substance is melting or vaporizing, you use either Q equals M times LF or Q equals M times LV. Reactions can be exothermic or endothermic. The defining factors as to whether a reaction is exothermic or endothermic rely on if it has a positive or negative heat value. Positive means endothermic because heat is being absorbed, whereas negative means exothermic because heat is being released. Endothermic reactions weaken IMFs, while exothermic reactions strengthen them. Despite the heat flowing in and out of surroundings in exothermic and endothermic reactions, the thermal energy of the system plus the thermal energy of the surroundings should always be equal to 0 because of the first law of thermodynamics. Let's think more about how endothermic and exothermic reactions affect bonds. During endothermic reactions, the system absorbs thermal energy, and consequently the temperature within the system increases. The heat weakens the bonds between molecules, which means that the molecules can begin to move faster, causing phase changes from solid to liquid to gas. During exothermic reactions, the system releases thermal energy, so the system temperature decreases. The bonds between molecules are strengthened, causing more rigidity and phase changes from gas to liquid to solid. Enthalpy is the measure of change in heat over any chemical or physical change. Every molecule has a standard enthalpy of formation, so to find the change in enthalpy during a reaction, use the formula delta H equals enthalpy of formation of the products minus enthalpy of formation of the reactants. Positive enthalpy means the reaction is endothermic, while negative enthalpy means the reaction is exothermic. Here's an example on how to calculate change in enthalpy. Titanium chloride gas plus water vapor goes to form titanium oxide solid and hydrochloride gas. If you enter the enthalpies of formation for each product and reactant into this equation, you should end up with negative 66.388 kilojoules per mole, and since it's negative, we know the reaction is exothermic. Next is entropy, represented by S. Entropy means disorder or chaos, and it depends on two things. As the substance moves from solid to liquid to gas, the molecules begin to speed up and disorder increases, meaning the entropy is positive. Another way to determine positive entropy is if the number of molecules increases. A decrease in molecules or a phase change from gas to liquid to solid will result in negative entropy. Let's determine the sign of entropy for this equation. Hydrogen peroxide liquid goes through a decomposition reaction to form water vapor and oxygen gas. The reaction went from liquid to gas, and there was an increase in molecules from 2 to 4, so the entropy sign is positive. Enthalpy and entropy are what is known as driving forces for reactions. Negative enthalpy or exothermic reactions are driving forces, while endothermic reactions are anti-driving forces. Positive entropy is a driving force for reactions, while negative entropy is an anti-driving force. We can see in this graph the different possibilities for reactions. If both driving forces are present, the reaction will always happen. If neither forces are present, the reaction will never happen. Temperature doesn't matter for reactions which will always or never occur, but for reactions that have positive enthalpy and positive entropy, a warmer temperature is required for the reaction to happen. Vice versa, in reactions with negative enthalpy and negative entropy, a cooler temperature is required.
Created using Powtoon.